if you hop onto Canvas and look for the tasks list for today, I'm going to share my screen really quickly just so I can walk you through this, but most of you know our routine by now. This is Unit 5, Lesson 8, so you're looking for tasks for U5L8. And I just want to make sure, Rube Goldberg machine, I went through and looked at photos. All the pictures I saw looked awesome. Some of you are pretty much like done and ready to go. Some of you at least kind of have like a base or like the first few phases, so that's really good. I am going to post an assignment after our next class meeting where you can then share a video of your machine on Flipgrid. My challenge to you this week is to finish the machine, but also, if you feel up to it, to decorate it. You can put colors on it, funny signs, add some toys and figurines. You can add some pieces that aren't part of the essential machine. In the past, students have usually tried to follow a theme, so like a graduation theme or like an ocean theme or a Tiger King theme or something like that. It's whatever you want to do. This is just added on stuff. But otherwise, just make sure it can run unaided for 15 seconds and accomplish at least 4 of the 8 tasks listed in the description. That's what I'm going to be grading you on. Please make sure you're checking grades and missing work if you haven't done so already. Some of you are already starting to submit some stuff, and I'll try to get it graded as soon as I can. I have graded your tests, so if you have not done so yet, you can actually click right on that link right there, the Science2C Orbit and Solar System Test Review. It should take you straight to our quizzes section. And don't freak out if you see like 75 or 65. Remember that it was out of 75 points. This was not out of 100. So divide your number by 75. Most people did great. I think the average was an A-, like 92 or 91% was the average. This was pretty good. Just to go through it, a couple little things I noticed, like a lot of you are feeling great about gravity and all the chapter 5 content. I thought some of the interesting things that happened was like on question 3, where you had to do the math about eccentricity. A lot of you included the unit. And can anyone remind me, when you divide kilometers by kilometers, what happens?
The units cancel.
It cancels, it's just a ratio. So you shouldn't have had units on your numbers. And I didn't really give you any explanation here. I want to know which one was more circular. The one that's closer to 0. If you remember your notes, eccentricity, the closer to 0 it is, the more circular it is. And so it is Deimos is the more circular orbit. It had a lower number. Nothing else really stood out. Everyone had good, I like your explanations for like the origin of the universe. That was kind of one of the more open-ended questions. The other one was which one of the outer planets you would go to. And the one thing I noticed that was some people selected Mars. Can anyone remind me, is Mars an outer planet?
No, it's an inner planet.
It's an inner planet. There are also a couple selections of Pluto, and technically Pluto is not a planet. So I was a little mean. I might have taken a point or 2 off on those. Otherwise, it looked good. And I gave extra credit where it was due. Any questions looking over? I encourage you to look over your quiz, because if I did take points off, I typically typed a little note next to the question. So you should be able to go and view my notes and feedback on quiz stuff. And you're welcome to contact me if you've got questions or want more of an explanation about stuff. But any big questions right now? Okay. So the next task then was a little do now that I want to dive into. I've got a video that I made. It's basically me reading the introduction to the case study that we're going to do about farming in space, specifically getting crops to grow on Mars. So you can read what I base this on if you want. There's a link right there, a problem statement for the packet. But what I'd like you to do actually is watch the video that's down here, Farming in Space Intro to Problem Statement. This is under number 2. And then there's a little link to a U5L8 Do Now Google form that I'd like you to answer. I'm going to time this for 10 minutes to complete this. The video, I think, is about 6 minutes long or so. So we'll come back together in 10 minutes to review. Go for it. All right, looks like we're feeling good. You all understand that, congratulations, we are headed to Mars. You are with a crew of 100 people, all adults that you can assume have no allergies or anything like that, that are in good health. You have a food supply to last you 90 days once you land on the planet. So I don't think that includes the journey, because the journey itself is about 8 months to get there. So let's assume we've gotten through that 8-month journey. But once you land there, you've got 90 days before you've got to start eating food that you yourself have grown. You have 1,000 acres of land to grow on, which I know is hard to imagine, but it's a substantial amount of space for crops, but it's not much compared to what you would have here on Earth for the mass production of crops, even for 100 people. And the most important thing is of the things to think about when you're going there, you've got to think about all of those, right? And most of you got that how much fertilizer has to be reused, how can you recycle everything, how long does it take crops to grow and produce food. Those are all important factors we're going to have to consider when thinking about what crops we need to bring with us. Any other questions or comments so far on the introduction? Okay. Again, I'm going to share my screen here just for a brief while to walk you through the next few parts. The next one, number 3, right there, Farming in Space, Developing a Sustainable Food Supply on Mars. That is a link directly to the PDF this is based on. I encourage you, this is what it looks like, Farming in Space, Developing a Sustainable Food Supply on Mars. Here's that same introduction that I just read to you. And we're going to do this in 4 parts. My goal today is to complete part 1 and part 2 in small groups. Part 1, you're basically going to be trying to predict what are the challenges. Part 2, you're going to start coming up with criteria for which crops you're going to select to bring with you. Part 3, which we'll do in our next lesson, is then using those criteria to actually pick some crops to bring. And then part 4 is sort of a reflection on the whole thing and whether or not you think this would work out. So I have created pre-assigned groups for you. However, I've shuffled some people around because we've got some people absent. So I have moved you over to replace Kwan with Owen and Shay. So I'll adjust this once I break you out into these rooms, but you're working in groups of 3. And each group is going to have 3 roles. And so I'll let you decide this amongst yourselves once you get together with your group. But kind of like the way we used to do Pogles, you're going to have a scribe who is going to be the one typing responses. You're going to have a reader who is going to be reading the questions out loud for the rest of the group through Zoom. And you're going to have a timer, someone who's going to keep track of the time as we work through these tasks. And so part 1, I've created as a Canvas discussion. So if you click on that link there, I don't have it open yet, so I'm going to open up a new Canvas board here just to show you where to go. But clicking that link should take you straight to the discussion board. And this is where you're going to post your response. So I'll let you follow the instructions and figure out how to do that. But just make sure that everyone is at least here. So you're looking for a discussion board called Sci2C Farming in Space Part 1 Sustainability Considerations. So please just decide who's going to occupy each task, read the instructions and answer the questions, and your scribe will post a reply. So rooms are open for the various groups, and I will come and check in with each of you. Timers we're going to set for 10 minutes. That I thought were pretty informative about food and space. And I don't know how many of you are now convinced you want to be an astronaut after watching some of that, but most of you had the takeaway that when they did the first Apollo missions, what were the astronauts eating?
Like
mac and cheese.
Yeah, but what was the food in during those first Apollo missions? Like, what was the food actually? What form was it in?
like tubes and like stuff like that, right?
Yeah, it was like paste. So it might have been mac and cheese, Andres, but it would have been like a mac and cheese paste, like in a toothpaste like thing that you just squeeze out in your mouth. It wasn't exactly pleasant, but their only goal was just to keep the astronauts alive and healthy. They weren't really worrying about whether it was pleasant to eat or not. It was more just like eating a protein pack. Now that we've gotten much better at launching fresh food into space. You saw like Chris Hadfield, he's a Canadian astronaut who did a lot of cool videos, tomatoes and things like that up there and putting different meals together. But it's all about weight, right? They have to consider, well, what's the caloric value and then how much weight is it going to add to this rocket that we have to launch off the surface of the planet. And that's something that you're going to have to consider as well as you think about, well, what crops do we want to try to bring to Mars? Because we're going to have to launch them off the surface of the Earth too in seed form with fertilizer and whatever else they might need to grow them. So did you guys see, how do they prevent the food from rotting? What do they do? What's not present in the packaging?
Oxygen.
Yeah, if there's no oxygen, the most molds and fungi and bacteria won't be able to survive, and so won't eat them. There are some bacteria that can survive in anoxic environments with no oxygen, but I guess it's not a problem with these tortillas and stuff that they bring up. So, and some of you kind of got at this. So, anyone know why would food taste different in space?
Oh, because of the smell.
Yeah, right. We learned at some point, if I remember correctly, this year that your smell is the major contributor to your sense of taste, and gases are going to move differently when you're in zero gravity, right? And I don't exactly understand what the key difference is, but the idea, and sorry, I shouldn't say zero gravity. When you're in free fall, when you're in experiencing weightlessness, there's just something about the way the gases move that, yeah, I think the changes the way that we perceive flavor a little bit. And I don't know if it just makes things duller, but something I hadn't ever really considered before. The next video was from National Geographic, all about, well, what if we were really going to farm on Mars? And it relates to the Martian movie that we've referenced before. But why can't we just throw seeds into the regolith, which is literally the surface of Mars, into that soil?
Is it because of the temperature?
Yep. So Mars is super cold. It has an average temperature well below freezing. So yeah, any plant seed from Earth is not going to grow well there. That's one reason. What's at least one more reason? I've referenced this before, but do you think is the soil on the surface like good quality soil?
The soil on the surface is like toxic, right?
Yeah, it's got a lot of bad stuff, and it's got perchlorate in it in particular. They didn't reference that in the video, but they referenced that it's really desiccated, that's super dry. But yes, those are all reasons. We would have to dig down and take the soil from the lower layers. That could potentially be good for growing. And I guess in the Martian movie, that I guess you can assume that's what he did, was that he was taking soil from the lower stratum that he dug down to it. So it turns out, though, that algae farms are probably the best way to feed people. Would you be willing to eat an algae slurry? A lot of you, like, the unanimous decision seemed to be, when I was reading through your responses, was that if it was like life or death, I would do it. But otherwise, yeah, it must taste terrible. But I'm sure there's probably ways that they could flavor it or something that would make it a little more appealing, because you'll see one of the other missions or goals with this colonizing Mars is that it's not only important to keep people fed and healthy, but you also want to keep them happy. And you'll see there's some questions that kind of relate to that about, well, then what is it about our diet and the way we eat food that also kind of maintains our emotional health, because that's also an important thing to do. All right, any other questions or comments on those two videos? So with some of those factors in mind, I want to move on to part 2. And again, I'll have you do this individually rather than as a group. It's going to be a Google form. So on the tasks list, we are now on the last task, number 6 there, part 2, selecting criteria for growing foods. So you're not actually going to be picking the foods yet. What you're going to be doing is trying to decide what criteria you're going to use to select the foods. So like, what are the most important things to consider? Is it the fertilizer? Is it how much water it's going to make? Is it how many actual calories are going to be produced? And so I'm going to just share my screen here again really briefly to show you where you're going to go. It's a Google form that you'll click on. It's got a pretty long instructions list, but this is what you need to consider. I know I've got the timer, the reader, and the scribe. You can ignore that now since our groups didn't work out. The first question, it says, what are the names of everyone in your group? Just put your name for that answer there. Don't need to worry about your group. And then you're going to be writing a paragraph and listing what you think. So of these, I think there's about 12 criteria here. They're listed in capital letters. So water usage, fertilizer usage, space required, yield. You need to pick 5 of those. So which 5 of these do you think are the most important criteria to consider when selecting which crops to bring to Mars? And then just write a short paragraph about why you think those are important, right? Why are those the most important ones? I tried to give you a little definition of each of them. If you're not familiar with what yield means or what shelf life means, I gave you a little definition there to consider. But I will time us for 10 minutes. No, it's 27 right now. Yeah, that's perfect. So I'm going to time us for 10 minutes just to at least get started on that. and we'll come back together to reflect, and I'll let you know what the homework is. Go for it.